You see this car on the screen? Now at a point of time t1, this car starts with a uniform velocity of u, moves with constant acceleration till our point of time, which is of interest to us, that is t2. Now let's represent this motion of the car on our time velocity graph. There we go. So m is the point at time t1 and n is the velocity at time t2. Fine. Now the task that we have is we need to find the total distance that it has covered, and we need to use our graph for that. Now it's a velocity time graph. So this trapezium QMNP, yes, the area of this trapezium is what will give us the distance. And how do we find the area? Simple geometry. Area of this rectangle MTPQ plus area of the triangle MNT. Right? Now, if you look at the graph, initial velocity u is equal to mq, which is equal to tp. Fine. And pq is t2 minus t1, which is also equal to mt. Now let's first look at our rectangle. What is the area of this rectangle? Simple. U, that is one side, into t2 minus t1. That is simple. Now what about the area of this triangle? Area of the triangle? Half base into altitude. That is half into mt into nt. Now mt, if you look at the graph, is t2 minus t1 into nt. How do we find nt? Concentrate. nt is np minus tp. You agree with me? Now tp is, yes, u. And what is np? np actually is the final velocity at point t2, right? So we use our equation of motion, u plus at. That's what v is. So u plus a into the time interval is t2 minus t1. So this is np, u plus a into t2 minus t1. And from this, we subtract tp, which is u. So we get a into t2 minus t1 as nt. Now we substitute this in our triangle area. So half into t2 minus t1, that is the base, into altitude, that is nt, which we found as a into t2 minus t1. So what do we get? Simplify it further. S, the distance, is equal to u into t2 minus t1 plus half a into t2 minus